PN junctions are elementary building blocks of semiconductor electronic devices, such as diodes, transistors, solar cells, LEDs, and integrated circuits. A PN junction is a boundary or interface between two types of semiconductor materials, P-type and N-type. The P side contains an excess of holes, while the N-type contains the excess of electrons in the outer shell of the electrically neutral atoms. This allows electrical current to pass through the junction only in one direction. The PN junction is created by doping, for example, by ion implantation, diffusion. In a PN junction, without an external applied voltage, an equilibrium condition is reached in which a potential difference forms across the junction. This potential difference is called built-in potential. After joining P-type and N-type semiconductors, electrons from the N region near the PN interface tend to diffuse into the P region, leaving behind positively charged ions in the N region and being recombined with holes, forming negatively charged ions in the P region. Likewise, holes from the P-type region near the PN interface begin to diffuse into the N-type region, leaving behind negatively charged ions in the P region and recombining with electrons, forming positive ions in the N region. The region near the PN interface lose their neutrality and most of their mobile carriers, forming the space charge region or depletion layer. In forward bias, the P-type is connected with the positive terminal and the N-type is connected with the negative terminal. The holes in the P-type region and the electrons in the N-type region are pushed toward the junction and start to neutralize the depletion zone. With increasing forward bias voltage, the depletion zone eventually becomes thin enough that the zone's electric field cannot counteract charged carrier motion across the PN junction, which as a consequence reduces electrical resistance. Connecting the P-type region to the negative terminal of battery and the N-type region to the positive terminal corresponds to reverse bias. The holes in the P-type material are pulled away from the junction, leaving behind charged ions and causing the width of the depletion region to increase. Likewise, because the N-type region is connected to the positive terminal, the electrons are pulled away from the junction, with similar effect. This increases the voltage barrier, causing a high resistance to the flow of the charge carrier, thus allowing minimal electric current to cross the PN junction. If you like this video, please like it and subscribe.